Hello, welcome to another creature tutorial. In this tutorial, I'm going to go through the dragon UE4 sample, and we're going to start off with the dragon in creature first, and then move on to UE4 in the second part of the series. Okay, so the dragon is a sample you can actually download from the creature samples page, and this these are the mesh regions for the sample. As you can see, the mesh is remeshed at a texture of resolution of 50 by 50, which gives us a medium resolution mesh for these different regions. All right, it's very simple. You just bring a mesh in, the entire region, the image in, sorry, and remesh it. Okay, and let's go to the rig. So these are the bones for the dragon. Okay, this is how it's set up. You notice that I have a couple of intermediary bones over here. This is to basically animate the flesh of the dragon. We're going to put some motors on it later to give it sort of a bendy feel. Now the tail just has a series of bones running through it to make it very bendy, and the legs are composed of 3 bones. We're going to put IK on it during the animation phase. The same thing for the hands. It's just 2 bones. It's very simple. The mouth has 2 bones to allow the jaws to open and snap shut. And we have these intermediary bones to sort of allow us to twist and bend the neck flesh at the sides to make it more like a flesh type motion. All right. And the wings are interesting because in the animation you're going to see later for the dragon, we're actually going to expand and contract the wings. And in order to do that, I basically have 2 bones, two main bones coming out from here, and then I have bones coming out from the 2 main bones that allow you to sort of slide or expand and contract the wing membrane of the dragon. All right. So that's how the entire rig is composed, and it was all weighted using auto weighting. You should always use auto weighting to weigh the regions with the bones. Okay, let's talk about the animation. That's the most interesting part of the dragon. Now, by default, there is a default animation clip. If I play it, that's what you get. Okay, and this I'll keep this clip playing because it basically demonstrates quite a few features of the dragon sample. All right, first of all, we can see that the tail is wiggling about or waggling about. And how does this work? So let me stop this. Now at the base of the tail, I have a rotate cycle motor. All right, so if you click install motor, I basically have a rotate cycle motor, this guy over here. It says an oscillating bone rotating motor. And what that allows us to do is it basically allows us to rotate from, say, a start angle of negative 90 degrees to an end angle of 0 degrees. And you can set different parameters like the speed. I've set it to 1.5. So when you play it, this bone basically oscillates between the angles of 0 and 90 degrees, right? And so that's the base driver of the tailbone, right? Now the base driver isn't enough. Of course, the subsequent bones, the child bones, these guys over here, they have to basically wave and deform naturally according to the driving motion of the base bone, motor 29, this guy over here, which has a rotate cycle motor. These guys over here, should behave according to like a wavy tail, right? So a floppy tail, sorry. So what I've done is I put in a band physics motor. A band physics motor is the first one on the list of the bone motors, and what it does is it applies band physics to the bones. The other thing you should do, or what I've done, is I've changed the physics mode to motion, and that gives more dynamics to the behavior as the tail is getting wagged around by the base bone. Okay, so when you do that, you basically get this result, this wavy tail. Okay, so that's very simple actually. You just put 2 motors. Again, I want to repeat, you put a rotate cycle at the base for 1 bone, and then you put a bend physics, one single bend physics motor running through all these tail bones. Okay, and you set the physics mode to motion. And by doing that, you get this really cool tail wavy motion for free. Okay, so that's the tail. Now let's take a look at the legs. The legs are just traditional IK. in this case, okay, and they're pinned to the ground. Same thing for here. It's just IK, okay, so nothing fancy. Right, let's take a look at the other parts of the body, which are more interesting. I want to talk about the wings, actually. The wings are very cool. And how is it done? Well, it's a combination of rotate cycle motors. We have one rotate cycle motor for the base bone of the wing, all right? So it rotates, in this case, from -5 degrees to 0 degrees. Then I have another bone stretching up the child of the base bone, and it's another rotate cycle motor, and this one rotates from -30 degrees to 60 degrees, okay? So by doing that alone, you can see how it's working, right? It's doing the rotate cycle motion. By doing that alone, you get a general expansion and contraction, but that's obviously not enough. Remember we have put additional bones in the middle of the membrane of the wing, right? This is to enable even better flexing, expansion, and contraction behavior of the wing membrane, right? So we have a rotate cycle over here, and we have a rotate cycle over here. And they basically, again, rotate between two different end angles. You can experiment with them. So, but a combination of basically 1, 2, 3, and 4 rotate cycle motors compose the entire wing. And by doing that, you get this really cool expansion and contraction effect on the wing. All right. So the other wing is done with the same technique. Okay. And you can tell that the mouth, the jaw is actually also done with a rotate cycle motor. Right. Okay, so this is the base or default animation. Let's take a look at the ground fire. That's where it's the most similar to this one. So this is when dragon's actually breathing fire. And it's actually very similar. It's just that the neck is slightly tilted up and the jaws aren't opening and closing. They're just opening once and they're done, right? Because it's actually breathing fire. Okay. So this one's simple, but let's go on to a more dynamic one. Let's take a look at the walk motion. So walk motion is more interesting. When we play it, actually does the dragon walking supposedly forwards, right? The tail stays the same. We're still using the bend physics for that, okay? But what's really cool about this is the walking motion. How is that done? Well, the legs, these two guys over here, they're done with a smooth IK rotate motor. Okay, so what it does is it puts IK on these two bones, but at the same time it targets a semicircular arc, which you can actually customize. So it's not really so-called semicircular. You can actually customize this sphere or ellipse. You can actually shave off the bottom, like what I've done. You can make the left or right less or more scaled up, okay, which is also what I've done. So if you take a look at this case over here, the scale left is 1, scale left is 1, and then scale right is 1.2. So I have more bias, more of a biasness towards the right of this ellipse. So you can see it's more scaled to the right, right? So when you play it, it basically tries to target that semicircular biased arc that I've customized, and that results in an IK motion that also targets a sort of a path, right? And that's how you actually do walking motion. Okay, so when we put those motors on these limbs, they basically do the same thing. But the other thing to really remember is that when you do walking motion, each opposite limb all alternates, right? They don't actually move in unison. And so the trick to that is to basically change the phase parameter of each motor. Okay, so you know it says the phase determines how the arc rotation animation state is started, right? So the phase of this guy is set to 1, and the phase of its opposite leg in the back is actually set to 0. Okay, so let me show you. What if we set the phase to 0 for this case? What happens? They're the same phase now. And okay, there you go. You don't actually get a walking motion. You just get two front legs moving at the same time, right? So if I change the phase of this guy back to 1, the other phase, and then you can actually get that alternate motion, and that's how you get a walk cycle. Okay, so the back legs are also done with actually the same trick, right? So when you do that, you actually get a quadruped motion. Okay, so having other phase motors for the opposite legs results in alternate motion that gives you a nice walk cycle. All right. Now the wings in this case are just rotate cycle motors with very, very tiny angles put into them. Now in the previous case, remember I had them set from like say negative 30 degrees to 60 degrees. In this case, it's just a difference of 5 degrees, right? And I also increase the speed of the rotate cycle motor. So when you do that, you actually get this nice wobbly feel of the wings. It just loosens up the wing quite a bit and gives it a very organic look. It makes the dragon feel very, very much alive. And finally, just as a extra addition to this entire character animation, I've also made the jaws just open slightly and close slightly, just to make it more alive. All right. So you basically get the entire dragon going forwards, so to speak, in this animation, ground walk. Okay. So the other one we can take a look at is ground reverse, which is really the same thing, except the dragon's doing this in reverse. Okay, and to do this reverse motion, the setup is exactly the same, except we actually just, all we need to do is change the speed from a positive number to a negative number. So in this case, the speed is -2, and the other guy's speed is also -2. So you just basically flip the speed of the motor from positive to negative, and you basically flip the direction. And that's how you get a backwards walking dragon, right? Okay, that's pretty cool. All right, and then we actually have an idle animation when the dragon's not doing anything. That's really simple. That's literally just pinning the legs down with IK, okay, and then just keeping the rest of the body doing very subtle motor motion. Just basically a huge reduction in the angles and the speed, and you have an idle animation. All right. Okay, so let's take a look again at the animations back to back, or let's switch between them much faster, right? So you can actually see what's going on. So this is a default animation. This is the ground fire animation. This is where the dragon breathes fire. Here's the idle animation where it does really nothing. Okay. Here is the walk animation where it goes forwards to the right. And here is the reverse animation. Okay. Right. And so when you're all done, you basically go in and you can export. I showed you the advanced export, but it doesn't require that in this case. A normal export is fine. Click on normal export and type in the folder you want to export that, and Creature will basically write out the JSON file and the texture file that you can use to import into Unreal 4. So I'll see you in Unreal 4. All right, welcome back, and we are back in UE4. All right, so here we're going to talk about how the demo was constructed. We have basically exported out our Dragon JSON, and I've actually zipped it up into a zip file. I call it dragon_data.zip. Okay, we also have the dragon image, the texture over here, that's also exported out, and I brought it into UE4. All right, so let's start with the easiest part, which is the material of the dragon. Okay, so let's take a look. So in Unreal 4, I have the dragon material, which I've created from the base texture. Okay, and so what I have here is I have the base texture over here. I also have a normal map texture over here. I actually made a normal map from the dragon character. You can make a normal map with any list of normal map tools. There's a ton of them out there from the base texture of the dragon. Okay, just to give it a bit more bumps, so to speak. And this is a very simple dragon material that I have. I have the base color hooked up here. I have the opacity hooked up here. Okay, and the opacity mask. And the reason why I'm doing that is because my blend mode is set to masked. Okay, so I have the opacity mask, and I have the normals hooked up to my normal map, right? And in this example, I'm actually using the shading model of subsurface profile. I thought it gave it more of a nicer, like organic look on the dragon. But you can experiment around. This is just a sample shader or material that you can try that I'm using to shade the dragon, but you can really do much fancier things. Okay, so we have the dragon over here. Now let's talk about the actual dragon character, the actual dragon object. So this dragon object is actually a creature actor object. Let me expand that so you can see that, a creature actor. Okay, and the way you create that is once you have the plugins installed, you just, yeah, search for creature actor and you just drag creature actor directly into the scene, and there you have it. And the only things you need to fill up for the creature actor object of creature, obviously, is you need to fill up the creature file name. This file has to be in the contents folder of your project, and you can either provide the raw JSON or you can just zip it up, and the runtime will actually read a zip file. So I highly recommend doing that if you want to reduce the file size. And the other thing you need to do is connect up the material that we created previously. Remember, I showed you I created the dragon material, so just drag that and drop that in to the materials slot, and you basically have your dragon. Okay. Set the appropriate scaling depending on your game. I have set that as 15 by 15. All right. And then I set the animation speed as 2. Okay, so before I go on to further details of this demo, let me play the demo to give you sort of a feel of what it actually is doing. Okay, so let's get on to the serious business of actually making this dragon come alive in UE4. The first thing I do is to convert it into blueprints, into a blueprints object by doing that. And once you've done that, you can add it the blueprint. So let's take a look at the blueprint setup for this dragon. Okay, that's very well, not that complicated, depending on what you think. But let's start off with the most basic thing. What is required? Well, the dragon responds to user input, right? Remember I said that pressing the keys of A, S, and D basically move the dragon. A moves the dragon backwards, D forwards, and S shoots the flames, right? So in order to do that, we have to enable user input on the dragon. And so in blueprints, the way you do it, well, before we do that, is in the event begin play. This is the event when the dragon character starts playing in the game. When this gets triggered, right? I have to tell the system, to tell the engine, tell Unreal 4 that I want to enable input on Dragon. And so the way to do that is I use this enable input node over here. Okay, with the player controller, which is really me, the player, set to me, right? So the player index is 0. Okay, so I link those up, right? And basically that's all that's required to make it respond to user input to keyboards, right? And so what's this after that? Well, I've made actually a variable in blueprints that stores essentially the mover. It's not really the direction, but it actually is a direction. It's a scalar value that represents whether I'm moving forwards, backwards, stationary, or shooting fire. So really it's a state variable. I shouldn't have called it movedir, but there it is. And this movedir is a state variable that represents the current state of the dragon. So again, as I said, it represents either when the dragon is moving forwards, moving backwards, stationary, or shooting fire. Okay? So you're gonna see that come to play later on as we examine the rest of the blueprint setup. Okay, so keep that in mind. But in the meantime, the first thing you need to do, again, I want to repeat myself, is to enable input on the dragon. And to do that, you want to do that in the event play callback or trigger event. When the dragon starts playing, enable input on that and make sure it's hooked up to the player controller, the correct player controller. Okay? All right. So let's move on to the other stuff right now. Let's see. Let's talk about the input events, right? Because that's the more interesting part. So, as I mentioned, when you press A, the dragon should move backwards, right? So we put an A node over here. This is the keyboard node, which responds to the A key press. And we say when it's pressed, what do we do? When it's pressed, we trace the arrows, the lines over here, and it says set blueprint blend active animation. And the name is ground reverse. This means that when I press A, it's going to move backwards. It's going to play the animation ground reverse. Remember? We had ground reverse in the creature editor, and that's the dragon was basically moving backwards in that case. The other thing is a factor of 0.1. What is that? So factor is the blend factor, or rather how quickly an animation morphs into another smoothly. right? So this makes the transition rather seamless, which is kind of cool. So I say I want you to transition to this animation, this reverse animation with a factor of 0.1. The range is basically from 0 to 1. 1 means it's going to jump immediately to the animation, and 0.1 means it's going to sort of transition is a bit slower, so it's smoother. Okay, so why do we need a blending? Because the dragon could be in any state, right? It could be an idle state, it could be moving forwards, it could be moving backwards, it could be breathing fire, and that's why we always want to blend an animation so that we don't want to jump abruptly to it. It looks a lot better. Trust me on that. So the blueprints function we use again is the set blueprint blend active animation function. And that enables us to blend smoothly by providing a clip name, again, the ground reverse, and the blend factor. Okay? So once we're done with that, we say press, what we're saying is on A, when A is key pressed, we will set the blend active animation to ground reverse, and then we're going to actually set, remember I talked about the move_dir state variable we had before? I'm going to say just arbitrarily, but it sort of makes intuitive sense. I'm going to say, well, when a dragon is moving backwards, left, or in reverse direction, the move_dir state is going to be -1. Okay? And you can probably see where this is going because in the next phase, when I say when A is released, that is when I let go of the release key, the dragon should transition obviously smoothly. So we use a smooth the blend active animation function. We want to blend it smoothly to the idle state, right? So now it's saying ground idle and factor at 0.1. But at the same time, other than setting the animation smoothly, we also want to set the move_dir state. And this time I'm going to use the value of 0 to represent an idle. Okay, so -1 to move backwards, 0 to be idle. Okay, you can probably guess already what's moving forwards, right? When D is pressed, when I go forwards, I'm going to say set blueprint blend active animation with ground walk and factor of 0.1, this moves forwards, and I'm going to say the move_dir is 1, right? Because it's positive, it's moving forward. So again, let's take a look again. When I move backwards, the state is -1. When I'm idle, the state is 0, and when I move forwards, the state is 1. So -1, 0, and 1. And you're going to be asking the question, what's the point of this? Why am I having these states? Well, you're going to see in a moment, we're going to use these states to do cool stuff with it. Okay, so hang on to that thought. Okay, so continuing to the key presses, again, when D is not released, sorry, we transition back to the ground idle state and we set the move_dir to 0. All right, okay, so we set those states. And then finally, the fire animation, fire breathing part. When I press S, it breathes fire. So I say transition to ground fire, play the animation, ground fire, and then I want the move_dir to be -2. It's just something I want it to be, -2. Okay, it's just -2. And when I actually release it, I transition back to the ground idle animation and I set the move_dir to 0. Okay, so 0 is idle. Okay, so you have the move_dirs all set. Okay, that's cool. We have animations are playing, but that's probably not enough, right? So there's something else that we're missing right here, which is, have you noticed, all we have done in this case was we've set the animations of the dragon, we've set the move_dir state, but we've forgotten one important thing, which is we actually haven't translated the dragon at all, right? The dragon is essentially stationary. It's not even moving, right? It's essentially not moving. We're just changing animation, but we actually want the dragon to move forwards and backwards or be idle or whatever. So that is why we have a move_dir. This is where this guy comes into play. How does it come into play? Well, this is where we actually use the event tick trigger. So what is event tick? Event tick is basically a callback or an event that is called every tick. Every time the character executes one time for a time step in the game, event tick is called. So it's like an update call, an update function. It's constantly getting called at every update. And we're going to use this update to basically translate the dragon. Okay? So how is this even done? Well, let's take a look at what I've done over here. And essentially, let's see. So essentially what's going on here, let's zoom out a bit and let's take a look at what is going on. We actually have, there you go. Okay. So what we're saying here is, okay, let's go through a couple cases. All right. So event tick, when this function gets called, updated every time step with a character, it goes to this branch, which is a logic branch. Okay. And what is a logic branch? Logic branch is basically an if then else statement, sort of statement. It's a conditional statement. You have a bunch of conditionals asking a question, right? So the first question we're going to ask is, hey, what's movedir? What's the value of movedir? Is it -2, right? So if movedir is -2, that's a condition. Okay, if it's -2, that goes to the true branch. Okay, so remember -2. What's -2? -2 was actually the fire breathing, the ground fire, the fire breathing portion of the dragon, right? That's -2. So we're saying, hey, if you're breathing fire, that's a true branch. So do something in a true branch. But let's talk about that later. All right, let's talk about the other stuff when it's not breathing fire. So it's false. We come here to another branch, and now we're saying, hey, if move there is 1, remember 1 is actually moving forwards, right? If you're true, do your moving forwards logic. Otherwise, else, if it's false, let's go on to another branch, the final branch. If you're -1. If you're -1 means you're moving backwards, right? So if you're moving backwards and it's true, do the moving backwards branch, okay? Right, so let's go back to the, let's see, let's try the moving forwards branch first. So if you're true, how do we actually move the dragon? So this is the actual logic that moves the dragon, right? So how do we move the dragon? Well, so we know we're moving forwards because move there is 1. Okay, we've determined that in this branch. So the first thing we do is we grab the actor location. That is the actor is the dragon, right? So we say, hey, Unreal 4, give me the actor location. Give me a location of yourself. So once I have the location, this is basically a position or a vector. Okay, what I do is I increment or I add another vector to it. And in this case, I'm adding a vector in the x direction of 2, a y direction of 0, and a z direction, a z direction of 0, right? This means I'm basically adding an x value of 2, incrementing it, incrementing a value of delta value of 2 onto the original location, okay? So once you've done that, the dragon moves just a bit to the right by 2 units in X, right? And then once you're done with that, we say, okay, we have that. Let's set this new location onto the actor, okay, onto the dragon, right? So the dragon sets this incremented positional value onto itself. So now we have a new location of the dragon. So it moves by 2 units, right? So okay, so now you're going to say, aha, but what is this? How does this even actually move the dragon? Because we just moved the dragon by 2 units. But aren't we supposed to keep moving the dragon, right? It's supposed to keep moving continuously by 2 units, not just move it once. How does this even work? Well, it actually does work because remember, as I said before, we're using the event tick mechanism to update the dragon, right? I don't want to say again, this thing over here, this node over here, this event is called every update. So it's constantly getting called. In other words, since it's constantly getting called, as long as your button is pressed down to move it forwards, this increment of the location is also constantly getting called. So in other words, the dragon is constantly getting added a value of 2 in the x direction as long as you're moving forwards in that branch. So that's actually what moves the dragon. Okay? So using the same logic, we do the exact same thing for moving the dragon backwards, except in this case, when the move dir is set to -1, I have the x value as -1.5. So we're moving him backwards just a bit slower with a delta of -1.5. And again, these 3 things are getting executed at every update when you hold down the key, right? So this moves the dragon, just keeps moving the dragon until you release the dragon in the negative direction. All right? Okay, so that's how it works to move the dragon left and right. And so now you can guess how the other stuff is done. So when the PS resistance of this whole thing, which is the fire breathing, right? We go to the branch over here. This is the fire breathing stuff. That's exciting stuff. Okay, so now you press S, what happens? Well, the first thing we want to do is we actually want to breathe fire from the dragon. So actually, let me pull up the dragon to show you what I'm talking about. So let's go back to the dragon over here. And when you breathe fire, we actually want the fire to come up from the jaws, right? Well, not necessarily the jaws, but maybe from the root bone of the jaw, because we want the fire to be emitted coming up from here. And basically, we want the fire to sort of span out maybe from this bone, right? So this bone is called bone 5, bone underscore 5, right? So if we go back again, you noticed the first thing we're going to do is to get the transform from this bone, from the character. So what I do is I use the creature function called get blueprint xform, okay, with the name of bone underscore 5. So this will return me an f transform value, the transform of bone underscore 5, which is exactly the bone we want to emit the fire, the flame from, okay? The other thing you need to check is world transform, because we actually want the transform to be in world space, not relative space. Otherwise, your flames will be in the wrong position. Now, lastly, we have a position slide factor of 2. What is this? So the best way for me to describe position slide factor is it's a factor that basically slides the return transform along the axis of the bone. Okay, so at 0, it's in the center of the bone. As you increase it, in the positive direction to 1, it hits the end of the bone, and you hit a 2, it just goes all the way here. And which is exactly what we want, right? Because we want the fire to come out from the mouth, not from the neck, right? But the neck is actually the right direction that we want to emit the fire from. So a value of 2, a slight value of 2, it basically comes out somewhere around here. So let's go back to Unreal 4 again, and this is precisely what I have. I have a position slide factor of 2. I grab bone underscore 5's transform, and then what I do is I break the transform because it's a matrix, right? And I'm really only interested in the position of that transform. So I grab the position. Now, here's the cool stuff. What I do again is I basically spawn an emitter, which is a particle effect, and I pick pfire2, which is one of the fire effects provided with Unreal 4. Basically, really cool flames, right? And then just for an added effect, I actually spawn more fire. I do the same trick again. This time around, I grab another bone transform, same thing, same deal, bone 5, but I increase the slide factor to 3.5. So this means initially I was at 2. If I increase it to 3.5, it probably goes a bit further here. So I'm basically spawning 2 flames here and here. Okay, let me go back again. I'm spawning 2 flames, and I break the transform, and I spawn the fire. Okay, so with that, let me play it. With that, let's play the game again. With that, that's actually what you get. So you move the dragon forwards, and I spawn a fire. You can see it's actually spawning due to the slide factor. It's actually spawning in front of the mouth, right? And I have 2 flames. It's merged together because they're really close, so it looks like one gigantic flame with 2 different slide factors, and that's actually how it's done. Okay, if I move forwards, you can see the animation. And I stop, it goes with idle, I go backwards, see how the event tick is actually updating the positions. That's how it works. And I do the flames, and there you go. Okay. All right. So that is basically the UE4 Dragon sample. I hope you enjoyed this in-depth tutorial. Thanks.